We are live, ma'am.
Okay. Good morning to those of you in US and good evening to those of you in India. Should we start now?
Yeah, just give me 1 minute.
Okay.
I just introduce you, ma'am.
Okay.
Yeah. Hello, everyone. My name is Papia. I'm a team member of IIT Madras Alumni Association Office. First of all, very warm welcome to all of you. On behalf of IITMAA team, I'm very happy to introduce Professor Anjana Susarla. She is a prominent alumni of our IIT Madras. She earned her undergraduate degree in mechanical engineering from IIT Madras in 1995. She received her graduate degree in business administration from the Indian Institute of Management, Calcutta, and PhD degree from University of Texas at Austin. Currently, she is working as a professor at Michigan State University in the Department of Accounting and Information Systems. Today, her topic of discussion is responsible artificial intelligence. All the attendees are welcome to type their questions in chat box. Ma'am will definitely try to answer those things. Now it's over to you, Anjana.
Thank you, Papia, for the kind introduction. Good morning, everyone, or good evening, depending on your time zone. I am so delighted to be here. So today what I want to do is 45 minutes talk is really very brief. I will try to give you an overview of what is algorithmic bias and what are some ways to, why do we have to care about algorithms being biased, whether you're in business, whether you are a technology designer, or whether you're just a user of algorithms. So that's this was some case that made international headlines. So I don't know if I can ask for a quick show of like a thumbs up or something. How many of you use voice assistants like Siri, Alexa, or Echo, or any of those? I would think several people. So this was something called a penny challenge or something that went viral. And apparently what happened was in many homes, whether in US or in India, we have all these devices and children are using sometimes electronic devices, gadgets without adult supervision. And so child was talking to Alexa and Alexa for some reason told the child to touch that live plug point with a penny. No, obviously you can get electrocuted. So the question is, how does something like that even happen? And that is an example of algorithms going wrong. Where did we really, what are the rules that drive all these chatbots? Did we have any sort of checks in place? Do we have some filtering mechanisms to avoid negative consequences? This is obviously a very extreme example, but the outline of my talk today, I want to just spend a little bit of time on definitions up front, because just some clarification, what is artificial intelligence anyway? We all have different ideas of what artificial intelligence is. And then I want to introduce some idea that algorithms can be biased and how do we understand that? Then I want to talk a little bit about what is fairness in AI. And if we have time, I will talk about just decisions, how AI is used in so many settings in today's world. If we have time, because I know 45 minutes is kind of a very short amount of time. This, talking about what is artificial intelligence, there was actually, you can Google Boston Dynamics robot dance. There was a really nice video clip on YouTube. I don't have time to play it, but it's really funny that robots can now even dance, right? The amount of advances in robotics and artificial intelligence is just stupendous. And so just to give some examples, my screen is frozen. Just give me 1 second. Sorry about this. My screen is frozen. I just wanted to show this like a funny meme. What is AI? What's machine learning? What's statistics? Underneath artificial intelligence is really a lot of statistics and maybe old-fashioned machine learning, right? So what is machine learning? What's artificial intelligence? Really, most advances in AI, this is almost a legendary computer scientist, Andrew Nug, says that almost all of AI's recent progress is basically when you're using what's called supervised learning. What is supervised learning? We are trying to find patterns between things. But for the patterns, we need some labels or what we call ground truth. So let me give some example. Say a doctor, in a doctor's office, there is a lot of, when people go to like an emergency department, they take all your vital statistics measurement and your history, and they'll try to predict, do you need any immediate, are you in danger of getting, let's say, a heart attack? How do they do that prediction? That's the process of what we call, we take data, we train a model. And the way we make these predictive models is that they are very, very generalizable, right? So there is what is called a test data set and a training data set. And we train the data and then we examine how well it's performing in the test data set, right? So supervised learning is when you actually need labels. So if there is image data, you need some labels for the images, right? Unsupervised learning, on the other hand, is when we do some clusters or patterns. We try to find like things together. And a lot of advances in artificial intelligence now is all these methods called self-supervised learning, reinforcement learning, where we are teaching the AI to learn better and better. And this may be a very, very, I've generalized across like so much, but evolution of AI seems almost magical. There was a time when artificial intelligence, really computers were just used for routine labor substitution. Now we are using it for Google Translate, we're using it for playing chess. So what's happening is that all these advances in machine learning, we are able to come up with these advanced reasoning capabilities without actually knowing much what happens, like Google Translate, which works so well. Now, has Google really worked with 10,000 translators? No. What Google Translate is doing really well is teaching itself patterns from so much data that we all input through our Google queries and searches and so on, and in our interactions with Google. So that's really the wonderful ability of artificial intelligence. It's the ability to make patterns, draw inferences, and how general can you make? So just to give an example, be something like all those, a lot of advanced AI has been spent in trying to find like cat videos, let's say on YouTube. Now, why is that important? If you're a child, how do you learn what is a cat? You learn through some sort of inductive process. How can we teach a computer to think like a child? Well, we can teach a computer to make essentially sequential learning process. So first the computer has to teach itself, these are different features, and then assign some feature weights and say that, okay, with this may be a face, this is like something, and so much probability this picture belongs to cat, so much probability this picture is a jaguar, so much probability it's something else. And this is the kind of inductive reasoning that has led to so many advances, whether it's self-driving cars, or whether it's all those advances we see in artificial intelligence coming up with genomic discoveries. Again, the ability to take a lot of different diverse groups of data and find some patterns through a process of some sort of sequential reasoning, I would say, right? So these are examples from GPT-3, and my examples I have not put from DALL-E. If anyone of you've heard of DALL-E, DALL-E is the latest, like DALL-E and Imagen, these are image generators. And you can go and put prompts and you can get images and AI generated images. And those are surprising, like how representative they are, right? General purpose technology 3 is one of those general purpose AIs. You can ask GPT-3 to write poetry. You can ask it to discuss movies, compose music, offer insights about life, right? So summarize the movie Matrix, or maybe we can get movie reviews from, one of my favorite sources is actually Instagram. There are a lot of Instagram influencers who do that for a living, and it's maybe very funny. So the day AI can take their jobs, I think then we know that society is in some sort of crisis, right? So state-of-the-art AI capabilities. I think some of you may be familiar with these language models, whether it's BERT or whether it's something more newer generation, right? The amount of computing power is doubling, the needed to train these state-of-art models. And some of the pre-trained transformer model, it has over 175 billion parameters. That is just mind-boggling. So the range of things that we can do with artificial intelligence is just, it's almost like these permutations and combinations. The range of things we can do suddenly is like all these exponential possibilities. So some people argue that we are on the cusp of a new AI-generated productivity revolution. In previous eras, when technological change happened, technological change is not always incremental. There is incremental progress, and there's also like the radical evolution of, think of the first human beings who invented the wheel, or first human beings who discovered fire, or even electrification that happened in the 19th and early 20th centuries, how much it transformed human progress. So there are people who argue the same about artificial intelligence. There are detractors. There are people who say that AI is going to lead to a world where there's super intelligence. And so what does it mean to be human? All these sound very, very profound. My objective is something far more mundane. It is that we as societies, or as consumers, or as I said, as users of technology, or whether you're business decision makers, we have less to worry about at this point in time from some killer drone, or we have less to worry about some sort of killer robots, but we have a lot more to worry about very mundane stuff, where there are the way we train AI models. Maybe there's biases in the way we create the models because we're not paying attention to maybe the context in which people are using these programs, or people are using this piece of code or software, or this piece of computer technology, or just this piece of information system, right? So there's so much of macro and micro data to influence decisions, from making movie recommendations to helping banks. So in today's world, if you've taken an Uber or an Ola, you are using AI. If you've gone to Google search and you're looking at some search keyword, then you're using AI. If you're doing almost so many of our decisions involve very routine automation of where we are using these predictive capabilities. The revolution in the business world has been that AI is so good at predicting. So the last 10 years or so, or last 15 years, there's been steadily companies are collecting more and more data about all of us. And then they're using all this data to make lots of predictive, I would say, to predict patterns, whether it's Amazon's collaborative filtering based recommendation system. So Amazon will recommend you some content based on what people like you have purchased. So these are all applications of predictive analytics. Now, what's happening? How are we building these predictive models? What is the data that's being used to train these predictive models? When we build these predictive models, are we considering how these predictive models are affecting people and their lives? How are these predictive models actually, are they ending up sort of worsening outcomes for some set of people? That's all the sobering stuff that I'm going to talk about next. I know that there's some questions. I know there's time for questions in the end, but if some of you can type your questions in the chat, I could just quickly look through when I'm talking about because there's just so much, I've spent so much of my work looking at these issues, and there's just really so much to educate and explain. So I just want to make sure that I am speaking to the concerns of this audience. So please feel free to put your questions in the chat screen. So the unintended consequences of AI, this is a very eloquent statement by, I think, a former AI lead at Google. The dangers posed by ability of AI systems to learn human prejudices are far greater than those posed by killer robots. There was this example of a chatbot that actually Microsoft put out, and the chatbot was supposed to be self-learning, right? So it learns from what people ask questions. And then what happened? Within 2 days, chatbot was spouting all kinds of racist nonsense, like neo-Nazi type of stuff, and they just shut it down. What caused the chatbot to behave that way? The thing is that chatbot does not have any intention to discriminate. What happens is it's only reflecting the prejudices of the people that are talking to it. So if the chatbot sees all these associations between what people are saying, and it programs itself to learn those biases and prejudices. And that's what my talk will be about, right? So one of the things in the United States was there was more than a year back, people actually went and attacked the lawmakers at the Capitol building, and that was deeply shocking. And so this is one of the interviews I did too. A lot of facial recognition software is actually used by not only law enforcement agencies, but since a lot of people posted pictures of themselves on social media, there were many amateur internet, like really detectives who worked with law enforcement to identify the perpetrators. But what is the danger? What's the downside of those? The downside would be that we really have now a lot of facial recognition used without thinking. We all tag ourselves pictures on Facebook and all these other social media platforms without thinking about what are the dangers in terms of surveillance or privacy, or is this consent? Are companies using all this information they're collecting from us? Are we consenting? What's the right use of information? So this may seem like an innocuous thing. There is actually a Canadian donut company called Tim Hortons. It is popular in parts of the US, only in the border states that are adjoining Canada, the northern part of US. So Tim Hortons, turns out, was collecting a lot of data about customers. Tim Hortons has an app. So if I'm a person who likes my donuts in the morning, and I get up and I, before I get in my car and I drive to the nearest Tim Hortons. So what was Tim Hortons doing? They were creating like a virtual event every time someone, like almost every morning. And they're trying to identify the probability, I guess, that you will visit a Tim Hortons, or send you, try to nudge your behavior. So, but the problem with the app was, even when users were not using the app, they were collecting data without the permission from people. And so these are the kind of privacy, surveillance. Customers of Tim Hortons did not know that when you have that app, that they're first collecting so much data. And second, they did not know the manner in which Tim Hortons is using to predict their usage patterns. And so these are some of the broader dangers when we talk about responsible use of artificial intelligence. But I want to give a few examples. The Microsoft chatbot, which I talked about, they were in the United States, there was an audit of some healthcare systems. And this was actually a very famous study done by some folks at, I think, the University of Chicago and other schools. So what they found out was, if you are Black, you are likely to get less healthcare for a similar condition. Why did that happen? It happened because the algorithms that were used to allocate care, to decide how much care a person receives, they were looking at historically how much healthcare that a given patient used in the last, let's say, 1 year. Now, what is the problem with that? Problem is that in US, there is a systematic discrepancy in how minorities versus the majority communities use healthcare. So for everything else being the same, Black people are less likely to go to the doctor. And so because of that, if you just look at the pattern of how much healthcare a person consumed, you may just miss the socioeconomic context. And therefore, it diagnoses a Black person who is sick as being less sick, thereby giving them less amount of care than what they needed to get. And that's a serious sort of a discrepancy. And similarly, you have other things where, facial recognition. There was actually IBM and other prominent vendors announced that they would be actually stopping sales of facial recognition systems, or they announced a moratorium on the use of facial recognition systems, again, because researchers pointed out how much facial recognition is very biased towards people with darker skin tones. On average, it does better in identifying people with fairer skin tones. And maybe my kids would say I should not use words like fair and dark. I should say maybe different lighter skin or something like that. So there are also similar cases like in the mortgage. People applying for mortgages, there were some discrepancies in terms of, the status of the person and so forth, right? This is actually a more frightening kind of example, but there was like an elite AI game. So then the drones taught themselves to start hunting people. And I know that the United Nations actually put out a very stern and serious report saying we really need to control the use of drones in war zones. So that's like a more scary use of AI. Right. So what is happening when we transfer decision making to artificial intelligence? There are a lot of emerging regulations now, especially in Europe, we see, where you can have a right to refuse. You can say that I don't want to be at the receiving end of an algorithm, or I want to talk to a human. You can insist on a right to explanation. You can say that if my credit card is denied or some mortgage application is denied, I want clear explanation why. You can also choose a human in the loop. And there's a lot of discussion on how to make AI more fair, more equitable, what is called more transparent. So we can explain to someone who is on the receiving end of an artificial intelligence system, we can explain to them what is happening, why the decisions have been made in using what inputs. There's also more, we talk a lot about also how fair or what's the distributive justice. So I'll talk about some of those things, right? So a few examples. This was a case of a supervised learning system that was using customers' data. And what was the problem with this? Well, it was good. It was doing a very good job from predictive accuracy perspective at approving these low-risk loans. Right? Now, on the face of it, this would seem like a very ideal use case for when we should use artificial intelligence systems. We have some loans that are very low risk for the bank. We have some high risk loan. If it's a high risk loan, we can use a human being. And if it's a low risk loan, we can use maybe it's just automated and no human needs to enter the process. But what happened? An audit showed that all these approved loans for male borrowers. Why is that? That reflects the training data that was used to develop the model. Historically, loan officers favored male applicants. So until there were some conditions where female borrowers needed to show that their permission from husband or father or something like that. So in other words, there is a historical bias in the lending, in how lending models were done or developed, but that does not address today's realities, when you have a lot of women in the workforce and applying for loans on their own, and so is there any systematic discrepancy? How do we address it, right? So this was another very interesting case. Actually, only recently, finally, Facebook has agreed to make some changes. What happens is Facebook provides targeted advertising services. That's what, since Facebook has so much user data, it allows what is called the ability to micro-target. But the challenge then, the Housing and Urban Development Department in the United States alleged that it's violating what's called the Fair Housing Act. Why is it violating Fair Housing Act? Because of the ability to micro-target ads means that if I am choosing to display my ad on Facebook, maybe I can choose to not show ads to certain demographic groups. That, the Department of Housing and Urban Development said, is what is violating the Fair Housing Act. That Facebook should not offer that ability to essentially exclude some people. What happens? I could be an African American, and then if I'm being micro-targeted, so I don't even see ads for housing. This actually happened some years ago with Google as well. There was an example where Google essentially is not showing ads for higher paying jobs to women. And that was, again, this discrepancy was brought out, and then Google actually agreed to change some of the way these results of display ads were shown and so forth, right? So there are laws in the United States, like the Fair Housing Law, which says that these are what are called protected characteristics. The characteristics protected by law are that race, color, national origin, religion, familial status, these cannot be used to discriminate a person. If there's a house and there's an ad, everyone theoretically has a chance to be able to at least look at that ad, and then there should be some sort of a fairness in the decision of whether they get that information or not. So this is a violation of Fair Housing Act, and I'm happy to report that this just only 1 or 2 days ago, I think finally Facebook has also settled with the Department of Housing and Urban Development, and Facebook has also agreed to make the full changes. And maybe I can just send the link to the IITM Alumni Association, and they can add it to my YouTube link or something like that. Right? This is another example which went really viral. This man who goes by Twitter handle DHH, he is the creator of this program Ruby on Rails, which is very, very popular with a lot of folks. So, sorry. So DHH's example in this example went viral on Twitter. He and his wife, they both live in a common property state, and they file joint tax returns, and they've been married for a long time. But when they both applied for these Apple credit card program, what happened? Apple gave him a credit limit 20 times what his wife was given, 20 times. And so he's like, what the hell? Like, how is this even possible in this day and age, right? So that's what you can see from this tweet storm. And he says that they won't even approve spending. Do you really trust women with credit card these days? And he went off on this tangent, sort of this Twitter rant. And it created so much backlash. This was actually, Apple developed this credit card in partnership with JP Morgan. And then the state of New York, where JP Morgan is based in, even announced they were doing some audit of JP Morgan's practices. And I think this whole thing really set off, as a bank, you are not allowed to, the same thing as I said earlier, like the Fair Housing Act, there is also Fair Credit Act in the United States, which is similar, which says that basically a protected characteristic, person's race or gender, these cannot be used to determine what allocative decisions are made by companies. So this, if the silver lining to this cloud is that I think the banking industry has done a fantastic job in the last 2 years of incorporating responsible AI practices and really looking at themselves with a very critical eye. And I think banking industry has been, in my experience, in my work that I've done with companies, they've been on the absolutely, companies like American Express, they've been on the cutting edge in terms of incorporating responsible AI principles into every part of their decision-making process. So I would say those are the great things. And I think this is, one of the reasons I do some of these talks is the same reason, that we have to educate ourselves about these biases. But educating about these biases doesn't mean that we just take a pessimistic view. These can be very much addressed. And it's just important for us to know that we don't have to continue these patterns of biases. So similarly, there was the example of Amazon. This was some years old. Again, I think Amazon scrapped this tool. This is supposed to be a resume screening tool. And what is funny is, because that job was a software job which predominantly men were hired, so the resume screening tool found the two factors that were most indicative of job performance is whether their name was Jared and they played high school lacrosse. So women applicants who were studied in all women's colleges, for instance, they were like sort of downvoted by the algorithm. And when there's also distinct differences in how women describe themselves, the gendered language, it was upvoting more confident, assertive terms used by men versus things that were used by women. So it's kind of funny story and good to laugh at. And it's also an example where, yes, we can have biases, but we can also correct those biases. So this was another example 1 year ago. This company was called Lemonade, and they were doing pretty well. This is an insurance company, but they made one huge mistake, which is they bragged on Twitter that there's no forms, they will do some emotion detection, and you can just speak to the camera and you will be approved for insurance through AI, and there's no like human beings required or something like that. And that set off a huge firestorm, and there was huge backlash. So I think one reason for responsible AI initiatives is also that companies that are seen as they don't care about fairness or distributive justice, there's also oftentimes a backlash from customers, and there's a loss of goodwill, and there's huge corporate reputation also suffers. So at least in the United States, that's what I've learned from all these high-profile examples and the companies I've worked with. So that's also one reason why companies are very worried about making sure that their AI efforts and AI ethics initiatives are in place. And I think Lemonade tried to do some damage control, but it didn't help. And this was the Stanford algorithm I already talked about earlier. Right. So just some sort of, I like using some of these memes, and this is a meme that went viral. And to apply those memes to AI, whenever someone says we're using AI instead of biased humans, then the question automatically we can ask is, what did you train the data on? Well, if you're training the data on just the past without thinking about where the biases come in, then you're just replicating the same biases that exist. So there is this notion of algorithmic harm. What is algorithmic harm? So when AI is used in things like employment discrimination or in social benefit discrimination or housing or education, essentially different people have different access to opportunities. Different groups of people are affected differently. And that's what we call algorithmic harm. How do we address algorithmic harm? I will talk a little bit about fairness. And given that we don't have so much time, it will be a very rapid tour of fairness. right? So we have testing and training. We take data, input data, we have a training method, and then we produce some output. We produce some output, and we train, and we test it on the testing data, right? So where are biases of data coming from? Oh, I know what happened. I wrote this in my Substack post, and it's just going to Substack. Just a second. I'll just need to do it one more time. There we are. All right. So this is a very interesting example, which I really liked. And what happens when you don't understand what your algorithm is learning, right? So this is an example where we can take data from, let's say, a lot of newspaper clippings. And we look at these restaurant reviews on Yelp or somewhere. And the training data is maybe from some, as I said, newspaper clippings. What happens when you don't understand? What is happening is we are looking at this tokenizing text to sentiment, right? So in the newspaper clippings that is used to train the data, the word Mexican appears many times in association with like some crime, because that's where people are talking about illegal immigrants. They did this crime. There's a lot of sensationalism and so forth, right? So what happens then? When we learn the sentiment score of the sentence, my name is so-and-so, that should be independent of what name is used, Emily, etc. But given that our training method is taking these tokens from like a Wikipedia or some place like that, we are learning a negative association even when nothing should exist. And that is how you can create a racist chatbot without even trying. So how can we address it? We can address it by essentially tokenizing, where we remove words like Mexican or Italian or Indian and just put token numbers. And that's how we can learn associations between things that are positive without in any way learning all the negative stuff from like the news media filings and so forth, right? So this is a good way for me to start talking about fairness. There is pre-processing before we train the data. There is during the processing, during the process of training the data, can we apply some fairness metrics? And there is then post-processing. So what are different things that we can look at? Pre-processing, we can look at disparate treatment or disparate impact. So we can look at, are there systematic discrepancies from the training data? And should we do some adjustment? Or we can look at the method by which we are learning and say, is there some sort of group level penalty term? And can we adjust that process and set some, maybe in some cases, we can adopt like a loss function, or we can put a bounded group loss or adjusted demographic. Or there is post-processing. Post-processing is a little bit like affirmative action with algorithm, where it doesn't matter what training method you use. It doesn't matter if your data set is biased. You can look at the decision rule and let's say post-processing is my decision of affecting different groups of people differently. Then I can do some sort of adjustment post-processing that's called equal odds or equal opportunity, right? So we can keep an existing training pipeline and have an anti-discriminatory step at the back end. So this is from the IBM AI Fairness 360. Machine learning model makes predictions of outcome for a particular instance, right? So the algorithm will attempt to find patterns or generalizations when a prediction, right? So this is how we are looking at essentially making prediction. So what's a good way for an introductory beginner to learn about fairness? I think IBM AI Fairness 360 tool actually has a lot of toolkits where you can play around and adjust for fairness. So I would certainly suggest that some of you go through that. We don't have much time. So I will just say that there are different methods like disparate treatment, disparate impact. we can have an industry standard, which is like a 4/5 rule. If an unprivileged group receives a positive outcome, less than 80% of their proportion to the privileged group, that is a disparate impact violation, right? So, for example, someone applied for a loan and was denied. And while attributes such as race are protected attribute, maybe the decision rules can be built on other attributes that are correlated with race, right? So this is called proxy discrimination, and something still a hotly debated topic. How do we adjust for a lot of other stuff that can affect creditworthiness and things, wherein we don't look at the protected attribute, but maybe we are looking at proxies for those protected attributes. So that's, as I said, proxy discrimination. It is sometimes very difficult to determine which inputs drive disparate outcomes. So sometimes the best thing you can do is that you cannot really adjust for all these outcomes. So you do some kind of post-processing performance adjustment. So the big question, a lot of business cases will be that what metric, fairness metric, is appropriate? Can I adjust my training data, or is it better for me to implement some kind of post-trading, post-processing rule? Right? Similarly, this is a different hypothetical problem. If you have a borrower who is supplements, she has two sets of income, basically. Now, how will the bank's decision to lend? There was a very interesting exercise. I know NPR, the National Public Radio, did a recent segment on credit scores. And one of the criticisms is that traditional credit scores can end up missing a lot of details about how people live their lives, and therefore they can be discriminatory to different groups of people. And there is a lot of debate, at least in the United States, that we can look at alternate credit score methods. So in this case, someone like Alice, if you are applying a rule wherein some non-regular income is not considered as a part, then we may be not giving her a loan that she actually deserves based on her income. So the question is, what are good rules by which we can consider? So should we consider some method of training, or should we look at post-processing? What are fair credit rules? And also, in this example, it's also building my algorithm. I need to consider the weights I place on different aspects of a person's life history or life, different ways in which they make income. That would make a difference, right? So if a lender can create procedure for verifying from multiple sources and measure income that's less consistent or formal, this may be a noisy estimate, but this can trigger a disparate impact claim, right? So making sure that you are looking at both employment, which is not just a formal income, but also informal income, will be, then as a bank, you are less likely to be audited saying your AI algorithms are at risk for disparate impact, things like that. So again, the prediction functions, we can look at the distributional assumptions that how did we train this prediction function? So is there a group of new applicants that we are applying this to? What is their probability of default? Can we do something that's like, say, race blind? So what can happen is my testing data versus training data. The testing data will have some race characteristics. Training data will not have race characteristics. So then it's possible to test the data in some way. It's possible to train the data in some way, but then we can test it in a different setting where we can plot the default distribution differently, right? So simple comparison one more time. Pre-processing, in-process, or post-processing. And I try to just very arcane and complex world that I have spent a lot of time working with companies. I try to distill it into 2 or 3 very simple examples. And I think my time is almost up, so I will pause here for questions. AI can be retrained or untrained. It can be rationally designed. Or is this yeah, seems a little philosophical question, but yes, I mean, we could always strive for, I guess, better. Can AI bring about social change? I mean, we do see a lot of conversations nowadays about what is called AI for social good. So I guess, yeah, it's definitely possible. So there was a question about Timnit Gabru's. Yes, and actually, the way that AI Google handled some of those was a bit. They fired a number of AI ethics researchers. So yeah, it is indeed a very good question. How do we? How do I think maybe one of the issues is that there was some pressure on companies as well now. And I think all the public sort of negative fallout is not great for their reputation. So one hopes that moving forward, they will be more cognizant of these issues. There's a question that the training labels are based on human bias. Can we be accurately fair? So the question is also, what is fairness, right? Can we, I mean, there was kind of unfair algorithms, or even before algorithms, there were different methods. In US, there is a lot of discussion around what is called redlining. That is the practice that banks and others adopted of treating like people from different areas differently. And we see that sort of now in a sense that when a lot of algorithmic decision making is used for, let's say, judicial sentencing, when judges have to decide after a trial is over how much sentence or how much time or community service somebody should serve. And there's sources of biases there, because oftentimes what happens is that we are looking at proxies for a person's demographic characteristics, including zip code where someone lives. And that can be very, very biased and so forth. So, yeah, to answer the question, how can we ensure more fairness in these kinds of cases? Well, it's not a open and closed, like black and white answer, but yes, we can definitely make some sort of allocative justice, right? Someone says AI cannot oust the president as it happened in Sri Lanka. I suppose not. The day AI can do that, then AI and biotechnology. That's a great question. There's also a question about ideal size of data set. Does big data make a difference? Well, definitely for some of the self-supervised models and so on, larger data sets are good. But there's always cases where like you have very good training methods where we are trying to learn from very small amounts of data. So you have all the, I guess, like what's called small data learning, or like one-shot training, or transfer learning methods where you learn from one setting and apply it to other settings. So there's a lot of different ways by which we can still learn efficiently from small samples, because in things like radiology, it's hard to get labeled data. AI and biotechnology is an excellent question, because we see not only robotics, like precision agriculture, precision medicine, precision science. There are a lot of examples where we can take all these, the processes of learning from, I guess, making generalizable patterns. I think that would be that's a great sort of there's like great prospects in biotechnology. I know that people are talking about artificial intelligence, especially in the context of resilience and food safety, because with climate change, there's more unpredictable variations. And so how do we use this precision agriculture or something like that? right? And what is the real difference between clustering and AI? I would say it's not really a difference. Clustering, you could consider clustering part of AI. Notice that in my talk, I've used the word AI in a very kind of a very broad sense, and different people have different definitions of AI. Someone's asking me, how can AI contribute to agricultural field in rural India? I'm not sure if this is really a development of agriculture, but I was reading about this fantastic example of there's a company called Kisan Pay. And what are they doing? So in rural parts in India, one of the big things for farmers is, they have to borrow money, maybe everywhere in the world, not just rural India. They have to borrow money to finance the process of, they have to buy seeds and then buy fertilizer and then buy inputs for the farming process. And there's an endless cycle of you borrow and you have to repay your loans. And there's like delinquencies or late payments or people being overdue is very, very common. So this Kisan Pay, they hit upon a very novel solution. They use AI to predict who is likely at risk of delinquency. But they have a very old-fashioned way to notify that person, because this is a farmer living in rural India. They are not using any apps or anything like that. What do? They'll send them an SMS or they'll do a phone call, just remind them, pay your loan, right? So is this development of agriculture? I won't say really it's so much, but there is a lot of, I would say, promising examples. I've seen one of my classmates from IIT Madras works with rural entrepreneurs, and they are trying to finance like new ways of sustainable agriculture and so forth. And there's wonderful opportunities for predictive analytics. And so I would say those are all great stories of like using of AI in agricultural fields. You can use better prediction models for food safety, coping with climate change, things like that. There are lots more questions. What steps can one take to make sure AI models are transparent and accountable? Yes. Can we detect bias in output? Yes. One of the things we can do when we detect bias is, we can do multiple things. So one is we can go back to model and pinpoint source of bias. We could build meta models, or we can just adjust our allocation post-processing where it doesn't really matter. We can keep the pipeline as it is and still have fair allocation. So those would be ways to. Someone says some amount of stereotyping is unavoidable. All discrimination are not considered unfair or evil. Well, the simple answer I have to that is, this is not so much about how we think as human beings, but are for companies when they're using very large scale black box AI model. When I use the word black box, it means we're using AI as a sort of general purpose technology without looking into how the system was built. So when we do something like that, at least in US and Europe, the two places I'm familiar with, we have to worry about there are already existing protections for customers, like the as I said, the equal credit, and there's also equal employment. There are fair credit, fair hiring, fair employment. There's Federal Trade Commission. So there exist all these regulatory bodies already. So even without new regulations, maybe like in Europe, there's a lot of new rules about AI. Even without that, under the laws that exist in the United States, with all these equal credit and fair credit, fair housing, the act that's already there for companies, if they use this discriminatory AI, then you can get a huge fine from the Federal Trade Commission or other commissions. So that's a very practical reason why companies have to care about fairness in AI. I am not as familiar in the Indian context. I have had conversations with the NASSCOM, and I know that folks are working on some of these best practices with responsible AI in India. I think there are rules in the Indian system as well, where we cannot discriminate in certain ways, which will not be considered, the law will not allow. So the question is, if you are subject to a decision by an algorithm, can you like go to court and say my rights have been violated? Those are possibilities that companies should worry about. That's also one reason to, other than the loss of goodwill, right? So this is not so much about stereotype, bias, or fairness, but it's a very practical reason why we have to care about this. There's a lot of, can we name modules in Python or R to identify biases before training model? I would suggest that you should go to IBM AI 360. There's very good like Python collab. Google research came up with also, there's a tool called What If, and that will also help with a lot of counterfactual, like asking all these questions, right? And so I would suggest that as my answer. Can you soil quality detection using sensors? I can respond to that offline. So in pre-processing, are there approaches to leverage machines to discover biases at scale versus people hypothesizing? Yes, I think there are a lot of pre-processing approaches where we can discover biases. That is like the examples I gave of disparate treatment, disparate impact. And there's a lot of established approaches to address those as well. And I'm happy to answer some of these questions offline. Also, will AI outperform humans in brokerage business? I think it's a combination of AI and people, and that will be more powerful than maybe only AI or any only. What has changed recently with focus on AI, especially in India? I think India has great opportunity for a lot of like out of the box AI applications, like in rural areas, in precision agriculture and climate change, food safety, security. IIT Madras, I've had conversations with the folks at IIT, and I would say that there's also a lot of ways like indigenous languages. I think they're doing some very interesting methods to use like NLP models with traditional languages and so on. So I think those are all fantastic examples. Is algorithmic trading a form of AI? I would say yes. Do you foresee a day where AI can be trained to recognize bias and self-correct? Well, it's a combination of AI and humans. So yes, I mean, we can recognize biases. We can do some correction for biases. And I think I'm exactly like 1 more minute. So if there's any last question or two. Yeah, there's a question about how can AI contribute to blockchain? I think these are two different slightly things. Like we can use AI in blockchain, but blockchain at the core needs that distributed ledger and that sort of a network of trust, if you will, so that trusted like connections. So AI may be used in a enforcement or monitoring, but these are also somewhat independent. That's just it's just 2 cents, very quick, like a rough assessment sort of. So do I have any other questions? Will I be able to share my presentation deck with participants? Yeah, sure. I'm happy to send it to the IIT Madras Alumni Association. So yeah, I think we are almost on time. Are there any last questions or anything like that? Yeah, I'm exactly at 10 o'clock, 1 hour. Thank you, IITM Alumni Association, for this wonderful opportunity to connect with IITM folks and everyone. I really enjoyed all your questions. Thank you very much for attending the talk. Thank you.
Thank you so much, ma'am.
Thank you. That's it. I think I see a couple of my classmates, but yeah.
So you can, if you want, I can unmute them. If you could tell me their names, actually.
I think they've left. I did see a classmate of mine. That's fine. No worries.
Okay, sure.
So, yeah. Well, thank you so much. Yeah, thank you.